dear viewers. Welcome to my YouTube channel. Today, I want to show you how you can obtain the reactions from your base in Autodesk RoboStructural Analysis Professional so that we can be able to design our isolated footing. So, let's start. So you can see I have a structure here. And by the way, I will compare this with my manual load takedown, which I did manually. So actually, we want to compare the loads that we are going to obtain. So I'm going to open this one with what I obtained or what I did manually. So as you can see, so let me drag this. So I want to go to load takedown. I'm still checking this software, and I see it's very consistent with manual design. So I think it can be safe for me if I will design my structure using RoboStructural Analysis. My structure will be safe. So I want to show you my load takedown, the values I obtained. Okay, you can see I designed my footing with RoboStructural Analysis. So I obtained after doing load takedown, I realized that my dead load, my factored load is 1883. That is the dead load. And you see I have a live load of 323, which is unfactored. This is not factored. This is not factored. So let's see from robot structural analysis. So this one I designed. I decided this to be my ultimate, and I think for me I used this column. I used this column, this one here. So we are going to check the same results to see if you are going to obtain the same results. So I will to check the reactions. You can see these working there with the structural analysis. You can see this one here. You need to expand here and go to loads. I mean, not loads, you go to results. And then in results, you can see results diagrams. So I'm going to click result diagrams. So I will go to show 3D. Okay. So let me first uncheck these ones. Apply. Then I'll go to parameter, none. Then just apply. Then let's close. Just minimize this one. So you can see my structure here. Let me select here. Let's first apply. So let's see. Okay, now close this. So we need to go to our reactions. So the reaction is just here, just have minimized it. This one here. You go to reaction. You can see here the option of reaction. Okay. So I will go to FZ because if you can see this one, this is the one which is in the gravity direction. This one is the Y and X. Now this one is the gravity direction. So I will apply. I can use description. And then it is very important that you decide which load you want. So let's first go for dead load. Then apply. So I have not checked any. So I will check these ones. Apply. So you can see my reaction. If I can go to, so this one, those are the reactions at the base. So I will just go to the base level. So I use the reaction for this. So my ultimate reaction. So my ultimate dead load here, you can see it's about, it is this one, it is 1604. This is unfactored dead load. So let's see the ultimate dead load. My ultimate dead load is 1604. And here my ultimate dead load I used is 1883. So you can see it's very similar, very close. Maybe I because I cannot say that I used here I used a wall load of I assumed a wall load of 10.56, but here in RoboStructural I used a wall load of 9.6. So that could be, there could be some difference because of that, because I cannot say that I used the same exact values that I used here when I was modeling and assigning roles, but you can see they are close, because in manual design you usually just pick the most critical and design. So if these I'm using circular columns, I use the same, but I use the most critical design. So you don't you need to check the reactions, and also you go to parameters, go to labels. So I want to check the local extremes, that is the minimum and the maximum value. That is very important. So I'll check the differentiate, check fill, and check this one, or I can just check it then apply. So if we go to our first full level, you can see the global extreme. So if you check this one, the 3D projection onto XY, you can see both our reactions and global extremes. So this one is what you need to print. You need to screenshot this one and print. This one is very important to submit. And I don't know the essence of these uh, um, global extreme values. If anyone, you can share in my message box. But I think uh, uh, they have a purpose. So that's why when you are screenshotting, you should, if you take screen capture. So this one I can just right click, zoom out. Then let me go to my base level. So let me use this one, projection of XY. So you can screenshot this for submission, or you can just go for the 3D and make sure you check here that only the flow you want is, so you filter the flows, all the stories. So so I will use these reactions to design my foundation. So after I screenshot this one, screenshot, comment, I will just write ultimate load, ultimate ultimate axial load, right? I will just put ultimate axial load, and then view updated vertical, horizontal, so automatic, and then okay. So if you go back to, so this one is not factored. If I select here the combination, you can see this one is dead plus live. So let's see the live load. Our live load here is 300. So let's compare with what I obtained in load takedown. So you can see my live load was 323. This one is 300. So this one is also not factored. This one is also not factored. So if you need the factored load, you can just let me go back to geometry, or let me go back to geometry structure. We can go back and go to loads, and then we can go to loads, and then we'll add combinations. With combination table, so I can edit. I will add another combination. Just this is for my live load, so just dead load, that is ultimate limit state. Then this one now will be case 1. My factor is 1.4. Then I'll go to live load. Live load. Now this one is by 1.6. This now it will be the factor. This one can be just deleted. So I don't need to. So okay. So you can go to analysis, calculations, so that the software will just give us the ultimate dead load and live load. We can use to design it. We can use to design. So number one is just one. I will choose. Let's go now to results, reactions. So let's do results, result diagram. So now here I can select my combination, that is so let me edit combination. I need to edit edit. So view loads combination table and edit. So the name here was, I should name it 1.4 times dead load. I will name it, yes. This one I'll name it as 1.6 times live load. So this one is case. So I can delete that. This one is live load. Okay, now we can go to info. So now let's go back to view, analysis, calculations. Then close. We will go now to results. We go back to geometry. View, so the whole structure. So uncheck filter. So let's now go to here, results, look diagram. Okay, so I can now go to first filter the stories. Okay, so reactions, FZ, reactions, description, then apply. So parameters, labels, differentiated, field, apply. So you need to make sure you check reaction in local system. So I've not selected any case. So I'll check the first case, that is the dead load, and I'll go to my live load, that is the ultimate, like my dead load ultimate. So you can see I'm obtaining a value of 2200, 1900, but I used a value of 1900 here. And then if I go to live load, then this one is factored, right? Yeah, I'm getting a value of 500 or 440. For if I go to my calculations here, I used a value of, if I can show you, this is just about structural analysis. Simulation lists. So I use a value of 500. So it is almost what you are getting here. So now to design the footing, so let me pick this one for 44. That is our live load and our dead load. Now that is factor dead load is 70 100, right? So I will go to structure, geometry, I'll go to design. Then I'll go to options. So I need to select at least one. So I need to go to my 3D view. So I check here, check button, and I will pick this. I will pick this column here. So right click, select. I'll pick it number 8. I'll go to design. So design option, code parameters. Make sure this one is RC columns, apply. And then I'll go to design and design. So no object have been selected. So we need to select. Right click, select. I'll select that one. Pick, apply. Then I'll right click, select, fix. So we want to design the footing for this one. So I'll go to design. Now RC column. Then okay. Then here you just need. So we must design the column first, then we design the footing. Okay. That's why I'm doing this. I go to parameters. I use C20, concrete plus 25, transverse. Transverse I just use 8. Okay. So here you can change longitudinal, number of bars. This is a circular column, so there's no point. Then okay. Then calculate. So my column is having 8 T20, as you can see. So we need to now to select this option, new foundation. Now I will use just those values, the ones which are here. I can just change here my column to be about, say, I just leave it the way it is, and then just apply. Then here we need to fill the data for our load. So our first load was factor dead load was 1700. From there, so add our live load was about 500, 490, and of course there is wind load because this is a high rise structure. So I did not add the wind load in my analysis, but I can just add here. Let's say about 200 because so this one is not just wind load case 3, and then this one is about 200. Then add. Okay, so you can check the load case. So this one was dead load. So I need to modify. The other one was dead load. So live load, this one I will delete. So I'm left with dead load. So the other dead load I will delete. So I'm left with just one dead load. So I needed to fill the data here, not like what. So this one change to live. Then case live load. Then here for 90 modify. Then we have another case, just the two cases. Then unlike. Alright, so I can now add another one, win load. Then here just 200. Two. So I need to delete. I need to add another load. Win load. Then case 3, then 200. Then so we have win load. Yeah, we have win load. So I can now close. Then go to my reinforcements. Fire. So here I will need to check the size of my. I can use both top and bottom if I want, but first let's do the calculation if this one is going to pass. So let me use fixed, then calculate. So let me go back to my loads. So I'll change this case to case. The live load will change to case 2. Now modify. Okay. Or I can just delete this one load. Delete it. So it's the one which is causing the problem. 2 modify. So I want to modify this to be 2, case 2. Okay. I will add win load. I will case 4. Then 200. And then add. Close. We calculate. No. So you can see from the calculation, we are getting a base which you don't want. So I need to fix this one. Let me just use 2, fix. Here I will use 0.5 and then fix. Then apply, calculate. So let's go to our cell. So I will use calculated, apply, because let's now calculate. So you can see the results we are obtaining. We have been able now to design an isolated footing. So you can see these are the notes. You can go to results, calculation notes. Okay. Then these notes you can print. It's printing, save the PDF wherever you want. So you can see I had saved another PDF, so I will just close. You can just go to the drawing. Now you can also print this drawing. So that will be it for this video. If you like my video, please consider to subscribe to my YouTube channel for more videos like this one. And thank you a lot.